Hear me okay? Good afternoon, everyone. My name is Al Flores. I'm a solution architect here at AWS focused on blockchain. And we have a pretty exciting session here with some interesting use cases. Some of you may remember about a year ago, I ran a session talking about blockchain and bringing that technology from just theory, skunkworks, and moving it closer to reality. And I think this is a great example of how we're able to move that session a bit further into practical use cases. So before we get into the real-world evidences and case studies that we have, we'll talk about what blockchain is, do a quick one-on-one. So what is blockchain? Well, it's simply the application of a technology in which a list of records, or as we call them, blocks, are sequentially linked to one another via timestamp and other key attributes, which defines the underlying protocol. Blockchains are inherently resistant to modification of the data, since the alteration of one block would require consensus across a recorded chain or ledger. This makes data in a block to be unable to be retroactively altered and reinforces the immutable nature of a blockchain solution. So blockchain is secure. It's able to be audited seamlessly and also can be programmatically accessible to see the underlying data through exposed APIs. So I'm proud to announce that today we've launched our AWS Blockchain Portal and our partner program. And the idea is to help support our customers and our partners on their blockchain journey on AWS. So there's a few key things with this program that we're going to be able to announce. We'll have some dedicated resources focused on enablement for our customers. We're also investing in this ecosystem. So if you guys have some time after the session, jump on the website. It's aws.amazon.com/partners/blockchain. And we'll have a whole field survey there for you to fill out. And give us your best ideas. Give us some proposals about what you think we should invest in and work with you guys. We'll also have the portal full information with reference architectures, best practices, toolkits, and accelerators. And we'll also have a marketplace full of turnkey blockchain solutions. And you'll hear more about that from a few of our partners here. And lastly, we'll also be announcing a blockchain competency program next year. And there'll be more information available on that. So what are we trying to do here? Well, at the core of what we're trying to do is allow experimentation for our customers to build, deploy, and install blockchain and move it from theory to actual production. So we've been actively working with several consortium, ISVs, and also advisory firms. And this is just a small snapshot of some of the companies we've been working with. And we'll continue to build these relationships and scale out our current blockchain involvements. Now, I won't get too far into this slide, but we have been working with Intel on developing a few assets that are available on AWS. And the first one we have, which is live now, it's on our marketplace. You can essentially click a button and one-click provision a full blockchain solution, is our supply chain track and trace that's sitting on Sawtooth technology. And next year, Q1, Q2, we'll be announcing digital assets and digital identity authentication. So I'll move to Kelly to talk more about Intel and what they're trying to do.
All right, great. Thanks, Al. So hello, everyone. My name is Kelly Olson, and I'm a director of blockchain technology at Intel. And today I'm going to be talking a little bit about Intel's mission in blockchain and what we're doing. And our mission is really threefold. The first is to accelerate blockchain technology with hardware and our processor technologies. The second is to show our commitment to open source by contributing to the blockchain community. And the third is by working with partners such as Amazon, PocketDoc, and T-Mobile to actually make it a reality. And today I'm going to talk about the blockchain protocol that we focus on, which is Hyperledger Sawtooth. I'm going to talk a little bit about where we think blockchain is applicable. And then finally, I'm going to wrap it up with some of the AMIs that we're launching with Amazon next year. But before I begin, I'm going to talk briefly about some of the ecosystem involvement that we have here at Intel. So at Intel, we're involved in a variety of different blockchain organizations and consortiums. And one of the first ones that we got involved with was the Hyperledger project. The Hyperledger project is managed by the Linux Foundation, who manages a number of open source projects. And we were one of the founding members, along with IBM and others, who actually set up that project underneath the Linux Foundation. We're represented both on the board as well as on the technical steering committee there. We're also engaged with, last year, the Enterprise Ethereum Alliance. Ethereum is an open source blockchain technology, and the Enterprise Ethereum Alliance is trying to take that technology and make it suitable for enterprise usage by adding things like permissioning, reducing latency, and adding confidentiality to its framework. Again, we were a founding member of that organization, sit on the board as well as the technical steering committee. And then finally, we're an investor in R3. R3 is an enterprise software company that's focused on building distributed ledger technology, focused on the capital markets industry. Their software was defined and assisted by 80 worldwide banks, specifically for capital markets, and we're both an investor and a strategic partner there as well. But the area that I'm going to talk about today is really where most of our engineering effort is concentrated, and that's on Hyperledger Sawtooth. So as I said before, Hyperledger is a project run by the Linux Foundation, but one of the key things to know about it is that it's an umbrella project. So many people talk about Hyperledger as if it's a single blockchain, but it's actually a collection of blockchain implementations. Hyperledger Sawtooth is one, Hyperledger India is another, Hyperledger Fabrica is yet another. And each of these blockchains has different characteristics that make it suitable for different deployment environments and different use cases. Sawtooth is a blockchain that was designed from the ground up for enterprise usage. So it's not as focused on public blockchains and cryptocurrencies like we see out in the market today. It's really focused on facilitating business-to-business transactions between enterprises. And the key focus on Sawtooth is really both on speed, security, and scale. So why Sawtooth? For us, the reason that we've invested in Sawtooth is that it enables programmers to program how they want. Today, many blockchain frameworks require you to write programs in new scripting languages and new programming languages. These languages are both limited in their expressibility as well as their security. We've seen hundreds of millions of dollars lost on the Ethereum blockchain this year because of the immaturity of their programming model. And what Sawtooth enables you to do is program in traditional languages like Java, Python, JavaScript, and C++, and enables you to define functions in such a way that they're secure. Sawtooth also supports a modular consensus interface that enables it to be deployed in both public open networks as well as private consortium-style blockchains. So who's using Sawtooth and how? Here are two examples of consortiums that are working on deploying Sawtooth into production. The first is the Open Music Initiative, which is a collection of over 100 companies who are trying to solve music rights management on a blockchain. For those that are familiar with this industry, today there's information about who owns the rights to a recording or a composition spread in approximately 100 different databases across the globe. And it's very difficult for streaming providers like YouTube and Spotify to know exactly who to pay. And the goal of the Open Music Initiative is to bring these companies together, labels like Sony and Universal, streaming providers like YouTube and Spotify, and create a sort of global database of the ownership of these musical works. Another consortium, far away from the media and entertainment space, is PocketDoc and the DocChain Alliance, which you'll hear about today. PocketDoc is a healthcare consortium focused on improving the efficiency of the healthcare system. Their two main use cases that they're focusing on currently are identity and claims adjudication. Ted's going to give you a lot more information about that shortly. So what are AWS and Intel doing? Our focus is really on making blockchain easier to deploy. And we're going to do that in three ways. The first is right now we've got two AMIs available in AWS that enable you to do one-click installs for development, test, and production networks. The tooling around blockchain today is not very good. And with these AMIs, you'll be able to quickly set up a blockchain network to experiment with the technology. The second thing that we're doing is we're loading these AMIs with pre-installed sample applications. These sample applications will enable you to do proofs of concept very quickly and inexpensively. And we'll talk about some of the use cases that we've identified for those. And then finally, a successful blockchain deployment relies on a lot more than just the blockchain, which is the underlying database. You need graphical interfaces, network monitoring tools, blockchain explorers, REST APIs, and as well as many other things. We're packaging all that together in AMI to give you one-click deploy for an entire solution. So before we talk about the solution AMIs that we're building, we're going to talk about, very briefly, what blockchain is and where we think it's applicable. So, as Ali mentioned, a blockchain is really a new type of peer-to-peer database. And what that gives you is very high availability. So if we look at something like Bitcoin, it's been running for about 9 years with minutes of downtime effectively. The second thing a blockchain does, which is quite novel, is it gives you shared control over the database. This means multiple companies can all participate in the same database without one having authoritative control. This is why many people see blockchain as a source of disintermediation, because typically there's a third party today that's managing those relationships. And finally, a blockchain gives you improved auditability. Every action on a blockchain is recorded in an immutable ledger, and this is very useful for understanding the provenance of physical or financial assets, and also helps in reconciliation between parties if their books get out of sync. So the first AMI that we've released today is a supply chain track and trace use case. What this enables you to do is to create representations of physical assets on a blockchain and track their ownership and custodianship as it moves through multiple parties' hands. Another thing that we've done is we've exposed a REST API that enables IoT sensors to submit telemetry data about those goods in transit into the blockchain, creating an immutable record of how that package was actually handled. We see many people looking at this for use cases such as fair trade, conflict-free minerals, and also things like understanding the provenance of 3D printed parts. The second use case is around digital assets. With this platform, you're going to be able to issue, transfer, and exchange digital assets all from a graphical user interface. As many people know, blockchain really started with a digital asset, a cryptocurrency called Bitcoin. But this has applicability to many other different types of use cases, from loyalty points to digital currencies to concert tickets and beyond. And we really see this as one of the very simple starting building blocks that will enable rapid experimentation. The third AMI that we'll be releasing is around digital identity and authentication. This is a role-based access control system that is built on a blockchain, can operate within a company or can be shared among companies. I'm going to not talk a whole lot about this because Chris from T-Mobile is going to talk about how they're using it shortly, but we actually see this as a really great way to create a system that enables authentication for access like streaming portals and sensitive content. And finally, the last thing that we're going to be releasing the first half of the year is a version of Sawtooth with Ethereum compatibility. What we're going to enable people to do is take the prototypes and POCs that they've built on top of Ethereum and to port those onto an enterprise-grade framework with higher throughput, improved permissioning, and consensus that works for the enterprise. This will also enable to use all the existing Ethereum tools that have been built for that ecosystem, such as IDEs, blockchain explorers, and Web3 compatibility. We're really excited about this capability and enabling people to take those proof of concepts and easily port them over to an enterprise blockchain. With that, I'll pass it off to Chris, who's going to talk about the hyperdirectory project.
Great. Thanks, Kelly. So my name's Chris, and I'm a senior architect at the T-Mobile Cloud Center of Excellence. And I'm here to introduce hyperdirectory. Hyperdirectory is a POC for a universal source of truth directory service. This is a directory service that would allow integration of web applications, IAM solutions, and your traditional LDAP-based directories. And we're pretty excited about what we're doing with it. At the Cloud Center of Excellence, we envision new ways to use the cloud at scale. It's not just that we envision them, though. We're architects and engineers, and so we build them. And part of our philosophy is that we then go share them with the community. That's really important to us. One of the tools that we've recently shared out with the community, it's available now on GitHub as open source, is called Jazz. Jazz is a serverless development platform that allows dev shops and organizations to build out their serverless APIs and infrastructure in new and easy to use ways. Not only have we released that as open source software, but we use that ourselves to build hyperdirectory. So we're all in on that. Now, despite this push to serverless, we still run something in the neighborhood of 20,000 unique instances a month on EC2. And that gives us a fairly unique sense of scale with which to approach the problem of how we can implement blockchain into an enterprise-sized environment. One of those problems that we see is that auditing is hard. Not only is it hard, it's expensive. Today, I don't have to tell you if you've used SOX compliance program, PCI, HIPAA, or any other one of these many compliance programs that might govern your business, that it might take ticketing systems, tracking requests, approval systems, applying permissions, identity systems, attaching to those, and change management tracking, well, all of those changes. And we haven't even started to talk about your infrastructure. So integrating all of these and finding a clear audit trail that connects logs from all these disparate sources is a big, complex problem. So we started building some tools to help us along the way. RBAC 2.0 is something that we built that is a role-based access control system. We use it internally, and it gives us the ability to dynamically apply permissions across all these instances in a pretty dynamic way. We no longer have tickets that track requests, humans creating groups and applying those to local permission sets on our instances. That all happens dynamically, and that saved us a huge amount of money and time. But auditing is still hard. We went to our partners then at Amazon and Intel and started some conversations about how we could use a Hyperledger Sawtooth blockchain to make some of those problems a little bit easier and less expensive. We shared with them our vision for how we could build RBAC 3.0, which we've come to call Hyperdirectory, from the ground up on a blockchain. We envisioned integration with AWS and those traditional LDAP-based directories that I mentioned earlier. We envisioned the same rules that apply your business logic to allow a workflow to complete to be implemented as smart contracts, right? Policy as code. Now that's something that really changes the way auditing happens and allows us to reduce the complexity of the environment. We envision being able to report not just on a current state, but on past states and every change that happened along the way to get us between those two stateful environments. And we envisioned integration directly with our RESTful web applications in addition to those LDAP-based directories. So what we then started to architect started with a network of AWS-hosted Sawtooth validator nodes distributed across regions. Now, you guys are all familiar with this type of an architecture. It's pretty common. One of the things that we did a little bit differently when we started to architect this solution is envision hosting a node of this right in our auditor's office. Imagine complete access to history, changes, and state information, and a new level of transparency into auditing in the enterprise. We have application workloads running in serverless, a cloud container platform, and EC2 spaces, all receiving permissions from this universal directory service. RESTful API integration then allowed us to create a WebSocket to publish Delta information from the blockchain. However, we ran into some early problems with that. Now, I'm not going to dig too far into how the Nakamoto consensus algorithm led to forking problems, and that had challenges as far as when and how we could publish that Delta information. But I'll just tell you that using Sawtooth allowed us to use a non-Nakamoto consensus, POET in this instance, to start working around that problem. Feel free to come talk to us later, and we'll tell you all about what we ran into there. However, we continued moving forward and built these APIs to consume and sync to directory services, and then imagined a future state where we had a RESTful layer that allowed native integration to web applications that speak LDAP. Hyperledger Sawtooth gave us high availability, fault tolerance, security, and transparency that previously have been unavailable in enterprise software. In the end, we built a single-page UI and hosted that in S3 using that Jazz platform. This allowed us to deploy self-service permission management for this directory service, all in a lightweight front end built over a robust API layer. We decided early on in our journey into open source that API-first design is something that would be really important to us, and it's really helped make a dynamic and modular kind of infrastructure set that we can apply into a wide range of solutions. We purpose-built this UI to a Swagger definition, allowed easy integration to the blockchain and other RESTful applications. And imagine a future state where we could have one-click integration and auditing that would allow us to eliminate weeks and months of investigatory work by expensive consultancy firms. Hyperdirectory gives us cloud-native enterprise identity with blockchain security and transparency. And it's open source today. We've released that out on GitHub, and we'd love for you to go check it out, create your fork, play with it, and let us know what you think. Contribute to the community. And yeah, hope you enjoy it.
Awesome. And that code is available on the portal, aws.amazon.com/partners/blockchain. We have Kevin here, who's a solution architect with PwC.
Yeah, I'm one of those expensive consultancy firm representatives. But hopefully not too expensive today. Hi guys, I'm Kevin Gannon, solutions architect and blockchain engineer with PwC. I'm based out of our digital engineering lab in Belfast in Ireland. So go Ireland. And as Al said, we were here last year really kind of talking about the skunk works, and more people were going with POCs and the underlying blockchain technologies that you can use. And I guess today what I want to kind of share with you guys is really how that is kind of progressing, and how certainly the thinking behind it has been changing and evolving over that past year. I think what we'll get to is really people want to see stuff not just in the lab anymore. Everybody wants to see things out of the lab, everything, how do we get to production? How do we make it real, as Al has said? So with that, what we've been implementing is a framework, if you will, of how we can kind of accelerate the development of blockchain applications. The idea is that, if a lot of use cases are fairly common around asset lifecycle management. How do you create an asset? Is that, be that a share, a claim, or a digital representation of a physical good, whether that's a digital twin, if you will, of something in real life, like diamonds and whatever ledger are doing in that space. So we're kind of looking at how do we build underlying blockchain interfaces with blockchain fabrics. So we're kickstarting that off with Ethereum at the minute, and we're using a pre-existing POC in order to migrate what was previously something run in Eris to something that will now be Ethereum. But obviously, as you can see, the plan would be ultimately that we could support multiple blockchains as and when they are applicable. So not only that, again, going back to POC land, everybody was kind of saying, right, I just want, can you slap a blockchain on this for me? I think, what we want now is really a platform whereby people can then take a POC that they've already built and then, harness or leverage the various, engineering practices that you would typically have around anything that's enterprise grade or production ready. So with that, the plan is we are integrating with KMS, and we're going to use some stuff around Kinesis, around near real-time streaming. And eventually, over time, again, everything starts with a sketch, but with stuff like Greengrass, you'd be able to really look at your IoT and connected devices around how those devices could interact with your blockchain, or indeed be an active participant in your blockchain application. So, as with PwC and AWS, everything starts with a client, customer first, and we really want to start with where are the problem sets. So we've partnered up with one of our clients, Guidewire, who are a big software vendor for the insurance space. And they were very interested in the work that we did last year around the claims-based claims management blockchain POC that we created ourselves internally. This was something that was built in conjunction with various UK consortia, London markets, and there were various workshops that were kind of worked out around how do we do policy placement? What does it mean to have claims management? At what stage do you need to create a claim, create invoices and stuff in the back of that? And Guidewire really saw that as something that they could potentially leverage with their claims center application, or indeed other products that they support. So we did that. We've done that in conjunction with them. They've integrated that into their claims center, and indeed it was a couple of weeks back here in Vegas at their Connect conference. They showcased that to their conference guys as well. So they certainly seem pretty pleased with being able to showcase how things can interact with existing systems, and again, taking things from a proof of concept state to more of a prototype state. So here's a bit of a flow of where we're all starting off. Again, from a blockchain perspective, we've got the kickstart of a claim. various invoices can be attached to those things, and at a certain stage, Guidewire wanted to be able to pull data out and interact with that smart contract in order to facilitate the movement of that claim through its paces via their internal claim center product. So really just to kind of showcase, obviously, plugging PwC, there's lots of kind of orange there and not so much blue on the Guidewire front, but certainly this was really a kind of showcase from a blockchain perspective, where are the flows that are in and out, and how Guidewire themselves are actually taking some of that stuff, using the events that are coming from the blockchain, using the APIs in order to integrate with it, in order to help facilitate the movement of the various claims through their paces. And as everything needs more diagrams, here's a bit of a snippet of some code that we have. So really just, I guess my real point here is that, building projects like this and writing code, and people might say that it's just a POC, but again, standard engineering practices apply. It's not just a bunch of Solidity files that are thrown together. People are taking this stuff seriously, and how do you kind of build this stuff into your code projects and stuff like that as well. So this is just a bit of a jump from my IntelliJ, just kind of showing a bunch of the kind of folder structures and file structures that you would have whenever you're actually building out some of your Solidity-based blockchain applications. Okay, so I guess ultimately the outcome from Guidewire was successful. It's given them something that they can take away internally to see, is this something that they can bring through to production themselves? They've been able to successfully integrate with a claims-based blockchain application. It was proof on our part that we could build a blockchain application that could ultimately be integrated into existing applications, and really enabling existing organizations to continue to operate as they do, but also being able to harness some of the blockchain benefits and features and functionality that come along by doing an endeavor like this. It was all smart contract based. I think something that they were very keen on was the auto approval side of things. So again, through smart contracts and automated checks and balances, as and when certain data is thrown through its paces, it's automatically be able to change its state, or check that certain checks have happened before actually moving it through its paces. So in this instance, if a claim amount was below a certain amount, it could be auto approved. And obviously the smart contracts can be written in any way that you want in order to facilitate your workflow. Okay, so from our perspective, the actual tech stack that we're using, I'm sure you'll see all of the icons and know what's AWS and what's not. But certainly starting with the blockchain side of things, we're using Ethereum. Like I said, it was originally ported from Eris, which wasn't a massive leap, given that it was the pair of them are Solidity based. But obviously from a migration perspective, there's different deployment mechanisms for deploying an Eris blockchain versus an Ethereum blockchain, how you deploy your smart contracts, never mind host them, and stuff like that. So a bit of work was done there, leveraging some open source projects around stats, being able to get some real-time monitoring and metrics from your blockchain pretty much out of the box for free. Node-based APIs, microservices, REST APIs that are written on the front end to enable you to extract data or interact with the smart contracts that you're writing. React.js from the front end, and then a whole bunch of AWS services. We're all we're spinning up Kubernetes clusters in order to facilitate the deployment of our containers. Using KMS for the likes of key management and encryption, and Route 53 for nice URLs and stuff like that as well. So yeah, I think as a stack, it's been fairly stable. Yeah, I think next steps is really where do we go from here? What tech stack do we need to embrace next? Is it go deeper on KMS? Is it the likes of Kinesis wasn't there? It was in the original kind of sketch stream that we had around where could this framework go. So really expanding on AWS integrations. And in that perspective, continuously validating that use cases that we're actually porting across fit an asset lifecycle management type use case, because that obviously keeps us honest. In terms of if you kind of, from my perspective as a solutions architect, it's very quick for me to jump to the end result of designing something, and then ultimately, if you build that, will they come? You don't know. Has the actual pain points that the customers have being solved there? So I think very much continually validating the use cases and the pain points to make sure that what you're actually planning to build still fits, and then compatibility with other blockchains. So the likes of Sawtooth multi-chain. Eris has obviously been there as well, and Hyperledger Fabric. You know, all of those types of blockchains are, you know, they all have their merit. They're all evolving at different rates and paces. They're all kind of suitable for different types of use cases as well. And you know, while we've chosen Ethereum, you know, you have to start somewhere, and it's certainly something that I'm a lot more familiar with than other blockchains. But I think it's really a kind of drive forward. If you have a platform that you can then slot in your various blockchain solutions, then the rest of the ecosystem can follow suit. So you're leveraging the rest of the AWS services and components to drive forward monitoring, reporting, and all that kind of stuff, while also supporting the underlying blockchain deployments and your solutions and upgrades of your smart contracts or whatever it may be. And that's me. Hand over to Ted.
All right, thanks everybody for hanging around late in the evening for some of you. My name is Ted Tanner. I'm the co-founder and CTO of PocketDoc, a doctor in your pocket, if you will. And we are an operating system for the business of health. So really, what is that? That's a $2.9 trillion opportunity. That is a T, not a B, boys and girls. Okay, what we're trying to do, and we've been doing this for about 7 years now. We have about 1,000 third-party applications running on top of us. We have connections to about 1,300 insurance companies, and we have 95% live coverage in the United States. So we're already up and running. Okay, and what we're attempting still to do is take that sponsor block and connect it closer to the provider block. The sponsor can be an employer, it can be a company, it can be an entity, or your mother. It can be a consumer. So what we're trying to do is connect the consumer closer to the provider and reduce that overhead in the middle. Look at those numbers in the middle. How many people have filled out a clipboard at a doctor's office? And the rest of you are lying. So where did this thing fall down? Well, for the past 30 or so years, this legacy system has not been chained together. And right now, we know that the health industry has been having a hard time spelling API, much less blockchain. And there's several companies in each of those siloed vertical areas. So we took it upon ourselves to build the best in breed in each of those areas. So we have provider search, we have the only clearinghouse, and in health, that is an oxymoron. There's nothing clear about a clearinghouse in health. You go, and then 90 to 180 days later, you get the bill. The AR window is not a day. It's like sometime in the future, right? So what we're trying to do is close that AR window. We have the highest certified level, CAQH level 4 clearinghouse in the nation. We have cash prices for a health service. Think about it. You buy a book on Amazon using AWS services, you know the price of the book beforehand, right? You go get your car fixed, you know the price beforehand. The most complicated machine in the universe, and we don't know the price to get it fixed. Your body, you, right? So we have cash prices. We have 10,000 cash prices across 48 urban areas on the top 50 bundled medical services via an API. We have scheduling and identity management. We're going to drill down on the identity management by consensus on the blockchain here in a minute. We've integrated 55 EMRs under one REST endpoint, so you don't have to. We have pharmacy processing for eligibility and claims and price. So now you can have the medical claim and the pharma claim right next to each other. And we have a payment backbone, PCI compliant payment backbone. And then all of those are rails. We have a probability graph model that computes the probability the consumer can pay for a service or that the provider gets paid from the payer. So I want to emphasize that we have APIs now across all of these, and now we converted all of these to smart contracts with an AMI on Sawtooth. So this is not something that's in the future that may exist. Execution is everything. This is what our cake looks like. We roll everything up, We roll all of those APIs up, smart contracts up into an Angular interface. You skin it, you colorize it, you put your logos. As one developer told me, he's got a great background in machine learning. He has 0 experience in healthcare. He said, "Thank you so much. All I want to see is a JSON blob return." I said, "Bingo. That's all you need to know." I don't want you to know about all the muck. We also have the next layer down. If you don't want to roll everything up, we have copy pasta widgets. It's even easier than Stack Overflow, boys and girls. You have transparency, you have claims UI, scheduling identity, and pharmacy benefits. Copy pasta all day. Write it right in your web application. The next layer down, if you so choose, is the dark underworld of electronic data interchange standards. It started in 1970, I think, right? So you really don't want to know about this stuff, but it always seems to me that interoperability is a problem in healthcare, and the VP of interoperability never sees it changing. Think about that. We're here to change it. And as I said, we have an AMI on Sawtooth available today. So what does that look like? Given that we have a network now, we believe that the conservative number of cost savings that comes out of the system is $174 billion. Some of the larger institutions that we work with peg that number now at $650 billion. Manual transaction processing, lack of care coordination. So what we want to bring is interoperability by design. The smart contract's the asset. That is where the new rules go. Enhanced security. If you're computing in the smart enclave with signed code, that is way more secure. 35 to 40% of all data at rest and in transit and health is unencrypted. Think about that. All right, one level down. Here's what the validator node and the AMI looks like on AWS and Sawtooth. Obviously, you got to have some exfiltration if you're connected to the lazy web. And I want, we also have Elasticsearch, Logstash, and Kibana. But I want to bring everybody's attention to IPFS. We experimented with every conceivable data store you can name. Neo4j, Titan, MySQL, Mongo, etc. You know, Redis. We're a polyglot house, so we experimented with everything. We landed on IPFS because that is an off-chain store. If anybody thinks they're going to take volumetric MRI data and put it on a chain in a hashed window, they're sadly mistaken. So we wrote smart contracts to synchronize the asynchronous behavior between IPFS and Sawtooth. And then obviously it's delivered via VPC. So 32 gig, 3 terabyte, to give you an idea, 2 million average health transactions is about 500 gigs. So you're eating through some good transaction size there. As I said, each node is delivered via one-click AMI. And here's the kicker for all the developers out there. Our BAAs and SLAs are transitive. So when you agree to our SLA, we've worked very closely with AWS on high trust, SOC 2, FIPS, et cetera, to get all the compliances so you don't have to. All right, so she who has the distribution wins, so we made an alliance. We have about 54 companies, payers, providers, systems, and large BPOs, and we're looking at 4 main use cases. I want everybody to key off the top one there, identity management. And of those 1,000 or so applications we have built on top and growing, and the 1,300 direct payer connections, we have the rights to most of that data reuse. And I'm going to get back to that in a minute. The next one, autonomous auto adjudication, is a tongue twister. That means we want to have the AR window one day for all health-related transactions that happen on this network. So you know the price, and you know it today, and you don't have to worry about it 90 to 180 days in the future. Supply chain provenance. We do pharmaceutical processing, claims and eligibility and adherence. We're working very closely with some companies on supply chain for provenance, as well as for the diagnostics, for MRIs, CAT scans, and other diagnostic devices. Where it's built, where it's delivered, who's using it, and where the content flows. Pre-authorization. Are you eligible? How much does it cost? And can you go? And can you pay today? All right, let's click down another level here. And yes, that is a summation sign. I'm going to explain to you what that means in a minute. And as I said, we have the data rights. We have very high quality data. So do other companies. We formed a network. We have a network now. DocChain is about consensus building. So we took it a step further, and because we always wanted PocketDoc to be on distributed ledger technology, we knew that identity by consensus was going to be extremely important. So womb to tomb, social security number, bank account, health ID, stock brokerage account, sometime in the future, death certificate, okay? However, what you do is who you are, so it's contextually relevant, all right? And what we have done is we are allowing all of these other entities who have high quality data to be an identity provider. So what S is, SQ on P, let's say it's a query, it's averaged over the number of providers in for the probability for a confidence interval of Q on PI, where PI is the number of identity providers. W transpose is a very important quality here. So the column vector with a W transpose allows us to have a time variant structure related to the context of the user vector Q as a function of consensus on the network. Everybody with me so far? We are calculating any new identity provider's data quality, and we're also ranking that as a function of the user. And we're doing that via key attestation to each identity provider. We're calculating the score as a function of the identity attestation key management. Okay? Some people call it multi-party identity. I like crimp, sounds cooler. But literally, we solved the continuum. Health ID, retail ID, voting ID, etc. So remember I mentioned the key management attestation issue. In addition to the design patterns that we created with crimp, we took this, we applied this to the very hard problem of device key management. So remember, we have a network now. We have an identity by consensus using proof of elapsed time, where we were the first company to actually have full stack proof of elapsed time with smart contracts on Sawtooth. So we took it a step further and we said, okay, key is going to be generated out of the secure enclave for Jane Doe. Then we provide that key attestation as a function of sharding across all of the identity attestations. If the device is thrown in the drink, we can recover that same key for Jane Doe independent of the device as a function of the network and with the attestation scores of the identity providers. How does it look? Each IDP gets a hash with respect to the key shard. You sling it across the network. Jane gets mad and throws her device in the drink. She hits go. Now, if you're paying attention, boys and girls, guess what we can do? We can do this every transaction, so nobody can actually track the key from an attack vector. As I say, execution is everything and code is law. We got to ship stuff instead of talk about equations. So we have the AMI with Sawtooth live now. One-click deploy, REST endpoint. 1.0 is coming out soon. Yep. We also have an SDK available, so a native Swift client that rolls this stuff up into a nice SDK. Crimp is going to be available Q1. We're going through some proof of values with several large customers right now, and that'll be deployed. Something very important, the W3C verifiable claim compliance. What this means is that Border Patrol, banking, and anybody else at that level can be compliant on a verifiable claim. And then something very important, but that I'm not going to get to, is the crypto asset framework. Originally, Hyperledger Sawtooth didn't have a crypto asset framework. We built one. Now, the cool thing we did was two things. For all you people who are going to go out and make a Bitcoin killer, this is going to be completely secure. It's going to be in the secure enclave. It's going to be ERC20 compliant. But here's the cool thing: when who's ever funding the company or whoever's doing the business modeling, we have pluggable minting models for behavioral economics. So you can experiment in real time on the chip with pluggable minting models. All right, coming full circle. Security, auditing, transaction behavior on existing infrastructure with AWS and now Sawtooth. Today available and shipping. Thank you very much.
Awesome. Thanks, Ted. So before we get into QA, the one thing I would say is there's a pattern here that I want to highlight from last year and this year. So last year we definitely, again, moved from skunkworks, talked about the applicability of blockchain. We talked about some novel concepts, and I think for this time we're really hitting the ground running around real life use cases and what blockchain could do. And next year going forward, especially with the program being rolled out, you'll see a lot more being done with across multiple verticals, industries, and specific use cases, and more importantly, doing this at scale. And we'll get into Q&A.
Not one question.
Any questions?
So I have a general philosophical question. So one of the long-term visions of the blockchain community is to democratize World Wide Web as we know it today. So democratize compute, democratize storage, like PocketDoc is already using IPFS, which directly competes with, say, S3 or CloudFront. I mean, we have already a name service on Ethereum called Ethereum Name Service, which competes with like domain name service providers. So do you guys think there is an inherent conflict between the long-term goals of the blockchain community and the long-term goals of these different companies providing cloud services?
So maybe I'll start on that piece. I think so. I think on the pieces that are related to sort of like democratizing or enabling multiple people to be providers of compute and storage and what have you, I don't think there's a conflict there, right? If S3 provides the cheapest storage, if EC2 provides the cheapest compute, then those will be the instances that make money with things like Filecoin and what have you. But at the end of the day, IPFS is just a system for addressing the content essentially, and so it doesn't really take a, likely there are economies of scale naturally for things like S3. And so it's going to be very difficult, for me to serve up content with the availability, the reliability, and the price off of my laptop, versus what S3 can do. So I don't think that there's a conflict there. I think with the other piece that you talked about, things like DNS, clearing houses, what have you, absolutely, I think there will be some disintermediation there. And I think that's why we're seeing a lot of enterprises that are looking to adopt this technology to perhaps not be disintermediated or figure out how to provide some of those benefits at a lower cost. So I think there will be some winners and losers, but I think from a compute, storage, networking, it's very unlikely that, in my opinion, in the next 10 years that I'm going to be doing 3D rendering on my graphics card on my laptop.
Yeah, so that answered the first part of your question. So the second part about the disintermediation, if anybody noticed, I mentioned that we have a CAQ, we're the highest level clearinghouse. We're going to disintermediate ourselves. So what does that mean about everybody else? And there were some very interesting comments at Help 2.0 this year about the roles of certain entities in the ecosystem, if you will. EMRs are going to be a node. But the largest impediment to a frictionless transaction are EMRs and clearinghouses. Because I can assure you the reason that certain transactional companies are sitting in the alliance meetings is they want to do it with a card swipe or bump. Does that make sense? That's about as avant-garde as I want to get about that. Thank you.
Cool. Anybody else? Questions? Quiet group. Okay, they must know.
They must know it all.
They must know everything blockchain.
They want to go drink.
It's getting late.
Yep.
All right, going once, going twice. Cool. Thank you, everybody.
Thank you.
Yep, thank you.